Now, there is lots and lots of different clustering algorithms, and you can try to organize or sort of bring order to this myriad of algorithms in several different ways. So here's one way of categorizing clustering algorithms. So you can have either monothetic or polythetic clusterings. So the difference there is if you have a monothetic clustering, you have your population, you've broken it down into subpopulations. In a monothetic clustering, all the individuals in a given subpopulation, they have some common property. In a polythetic clustering, there is no single common property, but all of the individuals in a subpopulation are sort of similar to each other. Where how you define similarity, of course, is an open question. But the trick is, in monothetic, there is one or usually one or a couple of attributes that are common to all individuals, and in a polythetic clustering, you cannot put your finger down and say that's the property that makes all of these instances fall into one cluster. So examples, for example, if you had a cluster consisting of males aged 20 to 35, that would be a monothetic cluster. Why? Because you can describe in words very simply what individuals go into that cluster and what individuals don't go into the cluster. For a polythetic clustering, that's not something that you can do at all. They're all going to be similar, but you won't know why they're similar. There isn't a single attribute or a single property that makes them all similar. You can categorize clustering algorithms by what kind of overlap they impose over the data. So you have hard clustering methods. In hard clustering methods, they partition your space. So a point is going to fall into one and only one cluster. Soft clustering methods produce overlapping clusters. So where a single point can be a member of more than one cluster, and in that case it becomes useful to talk about the degree to which an individual belongs to the different clusters that you have. So it could be part of this cluster with probability or with weight 0.6 and part of another cluster with weight 0.4. For example. So it's sort of a strength of association between an instance and the cluster where you're putting it to. Another useful way to categorize clustering methods is some methods produce flat clusterings of the data, some methods produce hierarchical clusterings. So a flat clustering is typically a partition of the space, so it's a set of groups that exist roughly on one level. So for example, you could have taken a bunch of animals and broken it down into the following classes, right? So you have parrots, penguins, sharks, whales, and dogs. A hierarchical clustering says, okay, that's one grouping, but you could further group those elements into sort of higher level sets. So you're talking about a taxonomy of clusters now. So you could say, for example, that parrots and penguins are birds, and sharks are fishes, not fishes, but close enough. Let's say that whales and dogs are mammals. So and all of them are this part of a broad group called animals. So the difference is you're either sort of cutting it flat and saying, okay, I have 5 clusters in my data, or your method could say, well, it depends on what granularity you want. If you want to be fine-grained, then yes, you have 5 clusters in your data. If you want to be a little bit less fine-grained, maybe you have 3 clusters in the data: birds, fish, and mammals. So that's hierarchical clustering.